Today we will talk about adding fractions. An important thing to know is that you can add fractions that refer to the same whole. We talked about that in our last lesson. And have a blank or blank denominator. Let's fill in those blanks. The mathematical vocabulary you're going to hear today is that they have a like denominator, also known as a common denominator. Common denominator, say that 2 times fast. Common denominator, common denominator. You'll hear that math vocabulary frequently. And this means the denominators must be do you know what goes in that blank? Same, or they must be equal. So let's think back to how we could decompose fractions, and you'll see you actually already have done some fraction addition. So in this picture here, we had to get up to 4/5, we could decompose that as 1/5 plus 1/5 plus 2/5. And you'll notice that all of these had a denominator of 5. Let's decompose these fractions into sums of fractions with the same denominator. So sum means that we're going to be using what operation? Addition, subtraction, multiplication, division. We're going to be using addition. I even have a song for that. I say sum, addition, sum, addition. So we know it wants an addition problem and it wants the same denominator. So there are many possible ways to do this. I want you to go ahead and pause the video and try these out on your own, decomposing like we've done in a previous lesson. Play back when you're ready to see how I decomposed. There's more than one possible answer. So, but the key was that you needed to have the same denominator and you needed to use addition. I'm going to choose to say 2/8 plus 3/8 would give me 5/8. Right? If that happened to be yours, give a woohoo. Let's try this next one. 15/13. I'll switch my color so that it's clear. So if I need to keep the same denominator, and I need to have addition, I'm just choosing to just add 2 fractions for simplicity. I'm going to add 10/13 and 5/13. But you might have had more fractions. You might have even had some unit fractions in there. Remember, a unit fraction has a numerator of 1. And give a woohoo if you happen to have that one. Okay, and finally, this last one's kind of fun because it is, do you remember what we call that when you have a whole number and a fraction? It's a mixed number. So my first step is going to be to say, well, 1 is the same as how many fourths? 1 is 4/4 plus 3 more fourths. I'm just going to write it like that to decompose it. Give a woohoo if you happen to do that too. And since these weren't the only right possible answers, give a woohoo if you decomposed into different sums of fractions with the same denominator. You earned it too. Right, let's keep moving on to some word problems. Read to understand, follow along with me. Mrs. George assigned 12 math problems for homework. Quinn finished 3/12 of the problems at school. She solved 2/12 when she got home from school. What fraction of the problems has Quinn solved so far? So what's the question asking here? What fraction, oh, I need my pen. What fraction of the problems has Quinn solved so far? So now we've read the problem. Now we need a plan, and one thing that your math journal will ask you to do is it'll always ask you to fill out the whole. So in this case, we consider like after the fraction what it's saying our whole is. So it said she did 3/12 of the problems at school. 2/12, it should say, of the problems when she got home. So our whole is the math problems. And if we're thinking of the whole, how many are there? There are 12 math problems. So 12 problems or 12 math problems is the whole. My trick to finding out the whole is always I look right after the fraction at what the words are, and that gives me a little hint. And then you just have to use your common sense and think about it. What am I talking about here? What would be being done with everything, the entire whole? Okay. Now it asks us for a number model with unknown. So to figure out what fraction of the problems has Quinn solved so far, I know that I'd need to use what operation here? I need to add. So I'm going to take 3/12 plus 2 more 12ths, because those are what she's done so far. And then it's going to equal some unknown. We'll call it question mark, but you can put anything there you want. So one way to solve this would be to draw a picture. So you could draw a picture with a circle or a rectangle, right? Any way to represent equal parts. I'm going to choose to draw a circle. And I know the whole has 12 pieces, right? So I'm going to split this up as best I can into 12 equal pieces. There we go. 3, and then 3. I think that's 6 on this side. 1, 2, 3, 4, 5, 6. Yep. And then do the same on the other side. I'm doing my best to make these pieces equal. Not perfect, but close enough. Okay, so now if I am thinking through this problem, I had 3 12ths, so I'll shade in 3 of the 12ths. And then I had 2 more 12ths, so I'll shade in 2 more of the 12ths. If you don't have different colors at home, that's okay. I'm just doing that for your benefit, but in your notes, you could just use a pencil. That's all right. And now I can see that I've shaded in a total of how many 12ths? 5 12ths. So my answer is that she's done 5 12ths of the problems, or of the problems. Right, I have to remember to get my unit. And hey, my unit's going to kind of match my whole up there. So I made a plan, I solved, and then I'll check, did I actually answer the question? And does my answer make sense? What fraction has she solved so far? 5 12ths? Yes, I think that makes sense. Let's look at another one, and we're going to look at a different strategy. So this was the draw picture strategy. Here's a new problem. Help me read to understand. Follow along as I read. After running 3/4 of a mile, Sia stopped for a drink of water. Then she ran another 3/4 of a mile. How far did she run in all? So the question here asks, how far did she run in all? I've read to understand. Let's go ahead and start our plan. So first we need to figure out what is the whole. Do you remember my trick for spotting the whole? Do you know what the whole is here? My trick is that I look after the fraction, so it says 3/4 of a mile, and that tells me that a whole must be a mile. Okay, and now our number model with unknown, if it's how far did she run in all, what am I going to do with these fractions I have? If you said Adam, you are correct. I'll do 3/4 plus 3 more fourths, and that is going to tell me my unknown, how many miles she ran so far, so I'll put M for miles, but you could use anything you'd like for the unknown. So another way to solve a fraction problem is with a number line. Let me show you that strategy. So if I just am already thinking about this logically, I'm like, okay, 3/4, that's almost a whole mile. And then she ran another 3/4, so it's almost a whole mile. So she's definitely going to run more than 1 mile. She'll probably get close to, and she will get close to 2 miles, but she's not doing 2 miles because these are not a whole, right? So that helps me know on my number line how far I want it to go up. And you just make an educated guess about that. So I'm going to make my number line go from 0 to 2 because, again, I know she's going to run more than a whole. But if you accidentally make your number line too short, that's okay. You can always add on more intervals later. Okay, so I make my big benchmarks. I have 0, I have 1, and I have 2. And now think, we have a denominator of 4 here, right? 3/4 of a mile. So that means I'm splitting the whole up into 4 pieces. So I'll split it like that. Now this is 1/4, 2/4, 3/4, 4/4, or a whole. So I know I did it correctly, right? And same here. I'm going to go ahead and label all of these just so I don't get confused. And then, can you help me keep going? What would the rest of the number line look like? Pause and try drawing it on your paper. See if you could keep going. Okay, does yours look like this? This is going to be, I have not I didn't leave myself enough room here, but this one's going to be 5/4, 6/4, 7/4, and that would put me at 8/4, which, hey, good. 8 divided by 4 is 2, so I know I did it correctly. Okay, so now let's show our problem. So she did 3/4 to start, so I'm going to put here, she'd already ran 3/4, but then she ran 3 more fourths. Now remember, each interval represents 1/4. So I want to do 3, I'll call them hops, or 3/4. 1, 2, 3. That's showing that she moved 3 more fourths, and then she ends up at 6/4 of a mile. So that's our answer, 6/4 of a mile. Now, if you want to be really sophisticated, we can take the 6/4 and know that that's the same as 4/4 plus how much more? 2 more fourths. And now, do you know why I chose this 4/4? Because that means that was a whole. So she ran 1 2/4 of a mile, or you might even be shouting, that's actually 1.5 miles. And the last way I'm going to show, I think this will be a favorite for a lot of you because this is the shortcut way. So let's do one more word problem and I'll teach you a shortcut way. That's my personal favorite. I bet it'll be one of yours too. It's important to understand the other longer visual ways we did before so that you have a good sense of fractions, but let's do this one. We have to read to understand, so follow along as I read. On pizza day in the cafeteria, Sophia, Lauren, and Bridget were very hungry. They each ate 3/4 of a pizza. Nice. What fraction of the pizza did they eat in all? What's the question asking here? What fraction of the pizza did they eat in all? Underline it. We've read to understand. Okay, see if you can pause the video and try the whole box and the number model all on your own and play back when you're ready to go over it. So we should have said it was 3/4 of a pizza, so our whole is a pizza. And the number model, because we want what they ate in all, we're going to add these numbers. And there are 3 girls, so we'll add 3/4 3 times to equal some unknown. I'm going to make my unknown a smiley face. Hopefully they're happy after eating all that pizza. And here is, like I said, my favorite way, the shortcut way. So we could just notice, now that we've done our visual models, we have a good sense of fractions, that when you add 3/4 all these times, I'm just adding my numerators and my denominator stays the same. Ta-da! That is the most beautiful trick of adding fractions. When they have the same denominator, it stays the same and we just add the numerator. So 3 plus 3 plus 3 is 9. This would be the same thing as 9/4. So we could know she ate 9/4, they ate 9/4 of a pizza. And this pattern is so important. When you add fractions with like denominators, you just add the numerators and the denominator stays the same. Excellent. And let's go ahead and take it even one step further. And 9/4 of a pizza, let's convert that into a mixed number. We'll practice this more later, so don't worry. But if it's not coming to you at first, but so I could think, okay, 9/4 is 4/4 plus 5. Ooh, actually, that's an even cool one. It's 4/4 plus, I was going to say plus 5/4, but 5/4 is still more than a whole 2. So maybe I'll say it's 4/4 plus 4/4 plus 1/4. So now I had 1 plus 1 plus a 4th. I actually have 2 1/4 pizzas. Wow, that was a lot of pizza. Lucky girls. So have fun adding fractions with these word problems.